you for tuning in to our recording today. Today we're going to be doing our 8th grade renewable energy lesson. But before we get into that, my name is Dawn Perez, hello, and I'm one of the education specialists at the Solid Waste Authority of Palm Beach County in West Palm Beach, Florida. And before we get into our lesson, let's talk a little bit about the Solid Waste Authority. So the Solid Waste Authority of Palm Beach County is a local government agency that was established in 1975 to manage all of Palm Beach County's waste. So that would include garbage, recycling, biosolids, and home chemicals. We are the largest county area-wise in Florida, and we're the 3rd largest population-wise. We actually have about 1.4 million people that live in Palm Beach County. And on average, each one of us makes about 12 pounds of solid waste. So if we do that math, if we take the 1.4 million people and multiply it by 12 pounds, here at the Solid Waste Authority of Palm Beach County, we get almost 17 million pounds of waste per day. 17, it's crazy. So for you guys to envision that, think about a football field, and that football field being piled up about 27 feet high. That's almost as high as the goalpost. The goalposts are about 30 feet. So that's how much waste the Solid Waste Authority of Palm Beach County gets in just one day. So we have to be very efficient about how we process that waste. And we have all different kinds of ways that we process waste. We have our recovered materials processing facility where the recycling goes. But today we're going to be focusing on our renewable energy facilities. And that we have 2 of them. And that's actually where we take your garbage and burn it and turn it into electricity. Now, we burn enough garbage that we produce electricity for over 70,000 homes between those 2 facilities. So that would be like the city of Boca Raton combined with the city of Palm Beach Gardens together. Okay, so let's get into our lesson now. Again, this is our 8th grade lesson for renewable energy. So we're going to discuss a few things first. Let's get started with some vocab words. First of all, physical change. What is a physical change? Well, a physical change is a type of change in the size or shape of an item or molecule. No new substance is made from this change. It has the same chemical properties as before. So an example of physical change is if I took this postcard and I folded it, right? Still made out of the same material, it's just a different shape now. If I tore it, that would be another example of physical change. Again, it's still made out of the same stuff, it's just a different shape and size, okay? What about a chemical change? What's a chemical change? Well, a chemical change is when a molecule undergoes a chemical reaction and becomes a whole new substance. And this change is typically irreversible. So once that item or molecule undergoes this change, it cannot go back. An example of chemical change? Well, what would happen if I lit this piece of postcard? Would it still be the same? No. The fire actually turns it into another chemical, okay? It's undergone a chemical change. It's no longer paper. You can't put this section back to what it used to be, right? So that is a chemical change. All right. Now we're going to discuss pH. I'm sure you guys have heard this in class. So pH stands for the potential of hydrogen, and it measures the amount of hydrogen in a solution. Now, pH is represented on a scale of 0 to 14, and this scale tells us how acidic or how basic a substance is. So here, if you look at this computer, you can see the pH scale, okay? Now, an acid is going to be anywhere from 0 to 6 on this pH scale. Acids have a lower pH, less than 7, and that means it has a lot of hydrogen in that solution. A base, however, is going to be 8 to 14 on this pH scale. It's going to have a higher pH, And instead of hydrogen, it's going to have a lot of hydroxide ions. Now, notice I didn't mention the number 7. What do you guys think 7 is on this pH scale? Well, if you guessed neutral, that's correct. 7 is neutral, which means it's neither an acid nor a base. And usually our drinking water or distilled water should be about a 7. All right, so we have some examples of physical and chemical change, and now I'm going to do a little demonstration for you. In front of me, I have some vinegar, some antacid, and a pH indicator. So what we're going to do is we're going to try to guess if vinegar and the antacid is an acid or a base. And we're going to figure that out by using our pH indicator. So let's go ahead and pour our vinegar in here. And now I'm going to pour our antacid in the other beaker. All right, go ahead and take a look at what this looks like to begin with. The vinegar is pretty clear. The antacid is a nice white color, right? So what do we think the vinegar is going to be on this pH scale? What are we going to guess? Is it going to be an acid or a base? Well, let's find out. We're going to take a few drops of this pH indicator, and we're going to drop it in here. And we're going to swirl it around. And just so you can see better, I'm going to put the paper on there. So let's look at that color. That's a yellowish color, right, that you can see there. So let's compare it to our pH scale. If we compare that solution to our pH scale, it looks like the vinegar is about a 3 to a 4, correct? So it's kind of a weak to medium acid on that pH scale, between a 3 and a 4. All right, now what do we think the antacid is? An acid or a base? Let's see. Again, we're going to take a few drops of this pH indicator, and we're going to put it in there. And we're going to swirl it around. And voila, you've got this nice color, right? Now, can you tell what that is? Kind of our purpley blue, right? So if we look at our pH scale again here, it's definitely going to be some kind of base, right? So it's a purpley blue. I would say it's probably around an 11 or 12, somewhere in there, which means it's kind of a strong base, okay? So we have a weak acid and we have a strong base. Now, what do you guys think is going to happen when we combine the acid and the base? Let's find out. So when we combine these two, what will happen is eventually you will get a green solution here. That green solution, what does that mean? When you add this base to this acid, what does it do? Well, let's look back at our pH scale. That looks to be about a 7 or 8, right? So that base has actually neutralized that acid. So this is a chemical change. We've taken an acid and a base, we've added it together, there's a chemical reaction, and we've actually neutralized it, okay? And that's what antacids do for our stomach, by the way. If you have an upset stomach and you take this, the base, the antacid, is actually gonna neutralize your stomach acids and make you feel better, okay? All right, so how does this relate to the Solid Waste Authority? Well, if you think about it, we have a lot of chemical and physical changes in our renewable energy facilities. For instance, I told you before that we burn garbage and turn it into electricity, right? So that burning process would be a chemical change. Now, when the garbage actually goes into the fire, around the fire, we have these metal tubes filled with water. We actually boil that water and create steam. That would be a physical change, okay? Because again, you're not changing the molecules, you're just changing the shape or size. So our chemical change would be burning that garbage. And our physical change would be turning that water into water vapor. And then later we use that steam to actually turn a turbine blade and make electricity. Okay, so that's what we do at our renewable energy facilities, and that's how physical and chemical change are incorporated in that. I hope you enjoyed your lesson today. I hope you learned a lot about the Solid Waste Authority and also physical and chemical change and pH. Thank you so much for tuning in. Just as a reminder, if you want to see other lessons like this, you can go to our website, swa.org/education. And we also right now are doing virtual programs. So if you go on Adobe Connect on Monday, Wednesday, and Friday, you can see our virtual programs that talk about different parts of our different facilities. And on Tuesday and Thursdays, we do Facebook Lives. So those are all at 11 a.m., so definitely tune in. And once again, thank you for listening to this recording and learning with me today. Have a good day. Thanks.